Pak Dim. Macam mana? Cakap je lah end product. This is the final product. Huh? Let's see what's it to the civil unit. We like to end up with the present for our analysis. This is the current operation from this presentation today. Make sure that you work on. Thank you so much. Assalamualaikum and good evening everyone. We are from ABBE Group Malaysia. Would like to thank you all for finding time and joining our webinar session today. First, let me introduce myself. My name is Nur Akila Binti Zahari and I will be the moderator for this webinar event. And I'm glad to welcome Dr. Muhammad Ifat bin Muhammad Ghazali, who will present for today's topic, the 3D printing, the next big thing. So our agenda today will be mainly focused on the basic of 3D printing and its potential to our industries. I hope all of you can stay with us throughout the live streaming, and as you will be exploring many things on the 3D printing, and we will have many interesting things to show, such as live model demonstration on how the 3D printing works. Just a little reminder before we get started. If you have any questions during the presentation, please leave them into the chat box of our Facebook Live and YouTube channel. Then I will bring them up during the Q&A session. Now, without the further ado, it's a great pleasure for me to introduce our speaker today, TS Dr. Muhammad Ifat bin Muhammad Ghazali.
Yeah.
For your information, Dr. Ifat is a senior lecturer of applied physics and health industry technology in University Science Islam Malaysia. He is also the director of the Smart Research Group at University Science Islam Malaysia. Dr. Ifat is mainly expertise on the 3D printing technology, in which he could share his experience on the 3D printing technology with us. It is such an honor to have you as our speaker for today.
Thank you.
So without further any ado, I am truly excited to hear from you the untold story behind the 3D printing technology.
Okay,
Sorry.
thank you so much. So, hi everyone. My name is Dr. Muhammad Ghazali. I'm a lecturer in University Science Islam Malaysia in Applied Physics and Health Industry Technology. Basically what she told earlier, and also the director of Smart Research Group, which stands for Smart Manufacturing and Advanced Renewable Technology. So, thank you for having me here. So, today we would like to talk about 3D printing or 4D printing, the next big thing. So I think you guys have heard 3D printing and 4D printing before, but let me just show you what makes this stuff very interesting. So next slide. So here's the content of my presentation of this seminar. First, I would like to talk about the introduction to all this stuff, 3D printing and 4D printing, and then I will talk about the potential of this 3D printing, and then the impact on it, and then transformation and summary and conclusion. So before we go for the next slide, before we go any further, let's talk about Industrial 4.0. I think you guys all know about Industrial 4.0, right? So basically it's where all the technologies are combined to make one new technology which can help human being in terms of application, in terms of industry, to make it faster, better, and more efficient. So here, Industry 4.0 can be categorized in 9 pillars, which is robotics. I think everyone knows about robotics. If you look at even in Kedai Mama, you can see all the robotic stuff where they send your mee goreng, your roti canai to your table without the server, without the people who can serve you, but they use robotic. I think you can see that in Kuala Lumpur. And then simulation, I think that's a lot of things we can do with simulation, where you can do molecular dynamics and stuff using simulation. Cloud computing, I think all your guys' phone has cloud computing in it. So you can store any of your data, any of your personal stuff, any stuff in the cloud. Next is the system integration. IoT, I think everyone knows about Internet of Things. All of the stuff will be, you can interact computer to computer, your phone can interact with other stuff, you can open your gates with IoT, you can survey your house, your camera using IoT and stuff, all that. So with IoT, you need cybersecurity. So that's the next pillar, where cybersecurity is very important to safeguard your data, to safeguard your privacy and stuff. Augmented reality, that's one of the best thing I think about Industry 4.0, where you can see all this futuristic stuff using augmented reality, without actually being in that place. Big data, I think everyone knows about big data, where you can personalize stuff, you can predict what will happen and stuff, so using big data. But here, in today's work, we're going to talk about additive manufacturing, which is the main topic of our presentation. Next slide, please. So additive manufacturing actually is a scientific terms for 3D printing. But before that, let's go and talk about the history of 3D objects, how 3D objects are being made. So next slide, please, on the 5th slide. So in the early years, people use handmade manufacturing. They use hammerstone and carve away all the structure. For example, if you look at the museum right now, during prehistoric time, they use hammerstone to carve away the structure. If you look at people use very sharp stone to carve away, for example, utensils, for example, arrowheads, for example, like very sharp stuff for hunting and stuff. That's the way that people use to make 3D objects. However, it's a bit difficult, right? For example, for me, I'm not very skillful. It's going to be hard to make an object or a structure to be the same every time you make it. Sometimes you have discrepancy, sometimes the material's not that right, so it's going to be a bit difficult. That's the disadvantage of handmade manufacturing. Next slide will be an animal-powered manufacturing. So before machines were made, they use animal to do all this hard work stuff. So for example, to bend metals, to use animal to create structures which is difficult to make, which you have to have a very high force to make, so they use animal-powered manufacturing. The bad thing about this stuff is that you have to use animal, which costs you a lot of money. You have to pay food for it, you have to take care of it, and you have to store the animal in certain places. So that's a bit difficult. Next is the modern manufacturing. That's what we have right now, which is you have multiple of manufacturing system. It starts with the Industrial Revolution, where you have IR 1.0, 1.2, 2.0, 3, and then right now is 4. So in modern manufacturing, I will little bit talk about modern manufacturing. The most common or conventional usage of manufacturing is subtractive manufacturing and formative manufacturing. But before that, let's talk about the future, which is the next slide will be atomic manufacturing. So this is actually the future of 3D printing or manufacturing, where you can customize individual atoms. For example, carbon, you want to place it in certain places, you can do that easily. So imagine what kind of structure or what kind of stuff you can make where you can individually place an atom at your own customization, when your own willing. So for example, you want to make an atom combined with different molecules, you can make that. That's the future, where you can place atomic based manufacturing using this. So this picture here is actually an IBM research, where they individually place an atom to form the IBM logo. So you can see the I, the B, and the M for that. So that is the future. I think in my opinion, in 5, I think it's right now they have this kind of technology, but it's not actually mature yet. But people are doing a lot of research into it. But maybe in 5 years time, 10 years time, you can create whatever structure you want. So that's the beautiful of it. So, but let's talk about the present day, which is the modern manufacturing. Let's talk about subtractive manufacturing. So in subtractive manufacturing, which is the slide number 9, subtractive manufacturing is a process in which a piece of raw material is cut down into desired shape and sizes. It's similar to like the old stuff where you have hammerstone, but rather than using your own hand, you are using a machine to cut away the structure. For example, here it's a CNC machine. For example, here you have a bulk, which is a material. For example, maybe a plastic or a ceramic or maybe a metal in terms of that. And then you want to design it into a certain structure. So you use like a driller, where you carve away the structure using that machine to form the structure. Here it's like a logo of my alma mater, which is the Michigan State head. So they carve away the structure. You have the bulk, and they carve away all the structure, and then you form the structure that desirable you want. For here is the Spartan head. But however, there's a lot of disadvantage. First, you can't really do complex structure. For example, you can't do crazy stuff like maybe like you have something inside or hollow structure, and it's going to be difficult. You have to figure, you have, when you try to design the structure, you have to know how the machine works. For example, how it will carve away the structure. So that's, you have to think about it first to make the design last. And with 3D, with substrate manufacturing, you lose a lot of waste. Yeah, you waste a lot of materials. For example, when you cut away the cut structure is actually waste. You can recycle them, but it's going to be a bit tedious. So that's a little bit of disadvantage with this, and you have to have a very good skill set in operating the machine. So next is the formative manufacturing, which is slide number 10. So formative manufacturing is similar to 3D printing actually, but the slight difference that the process involves mechanical forces that uses to bend and mold the structure into desired shape and sizes. For example, here I will give you guys is the injection molding. So usually what they do is that they use a substantive manufacturing first to draw the structure to form like a mold for that kind of structure, and then they place the mold together, and then they insert or inject the material, for example glass, plastic excuse me, what kind of material you want, metal and stuff, into the injection mold, and then you demold that and to get your own structure. However, like I said before, it's a bit complex. You have to consider how the design, you have to make it like how the design is okay with the injection molding. That's a bit difficult, and you have, and an injection molding or the mold itself costs you a lot of money. For example, you want to make certain mold, it might cost you up to 10 to 20 or maybe 100,000 to create a single mold. What if, the bad thing is that what if you make the wrong mold? It costs a lot of money, right? So you can't really know, okay, I tried to make this one, oh, it doesn't work. So something was wrong, or some design flaw happened, and you already lose a lot of money. So here, the other way is that you can do is using a different method. So next slide. So the 11th, slide number 11. So here you have handmade manufacturing, you have animal power manufacturing, modern manufacturing, and atomic manufacturing. Is there any manufacturing technique or manufacturing technology which is in between the modern manufacturing and atomic manufacturing? So slide number 13. Yes, it is. So like I said before, it's additive manufacturing. So let's go to slide number 14. So additive manufacturing is a process of joining materials to make objects from 3D model data, usually layer upon layer, to build a 3D structure. To make it more simple is that it's similar to having a printer, right? But rather than having a 2D structure of, like say you print using words and then you print your paper, right? Now you can print a 3D structure. So let me give you a simpler example that I think everyone here plays Lego, right? So you ever play Lego before, right? For example, you want to build a KLCC or KL Tower or stuff. You start to build the platform. So you build from the bottom. So build one layer at a time. So build one layer, the first layer, to build the foundation, and then you build up into the 3D structure. So that's similar to 3D printing. However, with 3D printing, you're just doing layer upon layer using a 3D printing technique. Sorry. So 3D printing sometimes, before in early stage, they call them rapid prototyping or free-form fabrications. People still call them that because for rapid prototyping is that you can create very rapid or very fast prototype using additive manufacturing or 3D printing. Free-form fabrication, because you can do whatever free-form structure you want to design, or you can design and create this kind of structure. So example here would be 3D printing. So a simpler way to say this is that whatever you think in your mind, you design it in the computer, and you can print easily. You can print the structure very, very easily. Next slide, please. So here is the process, which is the slide number 15. Here is actually the process where you model your structure using, for example, the free version will be Tinkercad for kids. So in Tinkercad, you have this simple rubric, like you have a triangle, a square, or a round shape, and you can subtract or add it together to form a structure using that. So that's Tinkercad. And there's other more free software as well, which is Blender. That's more for animation, but you can use that for 3D printing. For engineers, they use SolidWorks or AutoCAD. to design the structure. So then you can figure out what kind of structure you want, how it works, how with AutoCAD or SolidWorks you can know the stress of the structure, and then you can predict the stress. So that's a good way in modeling your structure. And then what happens is that you send the file in and then send it to the printer. Before that, you have to slice the file. A slicer is that it converts the 3D structure from AutoCAD or from Blender or from any CAD design software, and then you transfer that into a slicer, where the slicer will send it into the code into the 3D printer, where it can be printed. So in printing, you can, here is actually a simple FDM printer. You can print whatever structure. This is actually my logo for my research group. So it's actually a 3D printer where you can print like a leaf, which means like natural stuff. And then after printing, you take it out, and then you can do post-processing and get your end product. So there's a lot of other post-processing. I think you can look at it in one of the videos that this group have made. So this is very cool stuff. So next will be the history of 3D printing, which is the 16th slide. So the first 3D printing machine was born is actually in 1981, and then that was a prototype using an SLA, and then first SLA prototype, and then the first machine of FDM was in 1991, and then the first SLA printer is in 1992, and then the first laser additive manufacturing in 1997. That's basically the early stage of 3D printing 3D printing history. And then there comes to the middle one, which is the 3D printing, which is growing so fast, where you have inkjet printers, you have desktop printers, you have the first miniature kidney in 2002. RePrap project is founded, and then the first 3D printed prosthetic leg, and then the first blood vessel, and the first Prusa model, and edible 3D printing food. I will talk all about this printer later on. And then they can do like rocket jets, now zero gravity printer where they can use in space, ultra fast clip of 3D printers. Now they can print bones, farms, and also now the newest one is 3D print glass. So, but why is it important? Let's talk. I will show you in slide number 17. Why is it very important? Why is 3D printing or additive manufacturing important or have an advantage in terms of manufacturing by using this kind of technology? First, customizable parts. For example, what you want to customize, whatever you need, you can just imagine in your head, model that in the computer using the CAD software, and then you can do whatever you want. For example, every person have their own preference. So for example, you want to make like maybe like a bottle or a cup, or even like your iPhone casing, you want it to be different from other people, right? You can customize it easily. Rather than if you designed it and then you have to do injection molding, which is very, very difficult, you can't really customize it easily. So for example, something in your house is broken, or casing is broken, you can customize your part individually rather than having it to be done in a injection molding kind of technology. So that's the very important part. So nowadays, customizable is very, very important. So that's easy. Next is fast prototyping of complex structure. Here you can actually very, very fast in terms of determining whether your structure is workable. So here you can do fast prototyping, very, very fast, easily, and you can see whether it works. For example, if you want to do it in injection molding or CNC machine, it takes a while. And if it doesn't work, then you lose a lot of money, right? So here in this case, you can do a simple prototype, whether it works or not, test it. If it works, then you can do a mass production using all this stuff. The ability to revise design quickly, like I said before, if you want to do something and then you don't really know it works at the beginning, so like if you do in the software, it shows that it works. Sometimes when I do my research, when I design stuff, it looks like it's going well, but when you fabricate it, it doesn't really work as what you want it to be. So here, with 3D printing, it will be much easier. So you can just you design stuff, and if it doesn't work, you can just reprint it again, without thinking of oh, it costs anyway. It's just you have a filament which costs you very little money, and then you can redo it again. So that's very easy. Simplified assembly. like I said before, like Lego structure, right? So you have 3D printing, you can assemble stuff easily. So if you want to make a connector, or you want to make something to bond together, 3D printing is much easier to do that. You can make like a Lego shape structure, or you can make a joint together, something like that. It's much easier to assemble it. So you can customize your assembly to whatever you want it to be. Next, lightweight. Why I say it's lightweight? For example, you have 3D printing using plastic, right? So usually if you want to do injection molding, or if you want to do some structures, you have to make the structures to be very compact. So everything must be, the infill will be 100%. But with 3D printing, you can customize your infill, whether you want to save you a lot of money. So for example, a full 100% infill is good, but you 50% of infill will be enough, or 20% of infill will be just good enough for your product. You don't have to make it 100% infill. So now you cut a lot of cost in terms of material, and you save a lot of material waste, or you don't lose a lot of material. So right now people are talking about sustainability. This is why one of the factors that you can use in terms of 3D printing. So lightweight meaning that rather than having the bulk to be fully 100% infill, or the bulk to be fully everything to be inside to be infill will be 100%, you can customize that structure to be 20%, 30%, or 40% infill. So you cut a lot of cost. Now we talk about a lot of cost. Like I said before, you can customize whatever you want. You can customize the material, you can customize everything, and then the energy that it's used in terms of 3D printing is not that expensive compared to if you use injection molding. Will be more expensive. And for example, a 3D printer, a simple 3D printer will cost you around $200 or $300. Is around like 8 to 1,000 ringgit worth of 3D printer. That's things are getting cheaper. So the cost will be cheaper compared to if you want to make injection molding. It might cost you 100,000 or 50,000 or 60,000 or more than that if you want that. So 3D printing is very low cost. Next is multiple material. This is one of the best things, that 3D printing is evolving very fast. Usually in the old days, or in the beginning of days, they use plastic, right? The material will be mostly on plastic. Now you can have ceramic, you can have metal, different type of metal. You can different composition of metal. You can have different composition of plastic. You can have ceramic. You can have even food, and you can even have different cool stuff combined together. So a lot of research in 3D printing revolves around materials. So you can use maybe waste to reproduce good materials, that kind of stuff. So that's very cool. Next is less waste during manufacturing. Like I said before, if you use, like say for example, a CNC machine, you have a bulk and you cut away, you have unwanted waste. The unwanted structure that is considered as waste, right? So that's not good. And even that, when you have for injection molding, sometimes it doesn't work, you create a lot of waste because you have to cut all the unwanted structures. That's going to be very bad. So 3D printing is one of the best manufacturing system right now in terms of waste management. So next slide. So slide number 18 is that this is like a survey done by SME Corporation. The source is from Global Agenda Council of Future Software and Society in 2015. It's predict that there's some tipping points in technology shift expected to occur 2025, which is that things that related to 3D printing is that 5% of consumer products are printed in 3D. So how cool is that? Like 5% of whatever you have is made out using 3D printer. Next, the first 3D printed car in production. Imagine you can print a car. I will talk about that interesting topic afterwards in next few slides. That's a big thing. And now they are predicting that they can use 3D printer to make the first liver. So you don't have to have take other people's liver and then you can just print it. So how cool is that, right? So that helps in terms of manufacturing of new medical stuff. So then this digital transformation changing business and delivery models. So one of the main topic of digital transformation is 3D printing. So let's talk about additive manufacturing technologies, where you have different kinds of categories in 3D printing technologies. one of the first one I want to talk about is material extrusion, binder jetting, material jetting, direct energy deposition, wet polymerization, sheet lamination, and powder bed fusion. However, on next slide 20, I can't talk about all of them. I know it's very sorry. Sorry, I know that's very interesting to talk about them, but if I talk about every individual 3D printing structure, it will take like the whole day because it's very interesting. Even one 3D printer you have a lot of application, you have a lot of things that you need to talk about in that terms of 3D printing. So I will just focus on material jetting and wet polymerization. So for material jetting, I will talk about photopolymer jetting. For wet polymerization, I will talk about stereolithography, which is SLA. So slide number 22. For photopolymer jetting, this is one of the things that I used during my PhD time. There's two printers that I use intensively in my PhD, which is the photopolymer jetting by Object Connex 350 by Styrosis, I think. This, in terms of how it works, is that the inkjet print heads are used to jet liquid the photopolymer onto the platform, and the material is immediately cured by UV lamps and solidified, which allows to build layers on top of each other. For example, if you look at this schematic, where you have the green one, which is the polymer, the light green one is actually the supporting materials. Like I said, I want to draw this button head. So I will draw the structure using a model, and I send it to the printer. And what it will do that is that it will throw down the inkjet print, the liquid photopolymer onto the platform, and then after it touches the platform, there will be a UV curing lamp will cure it fast. So it will solidify and make the structure. So every time it does it, it will go layer by layer to form this kind of structure. It's very fast, very accurate. Even you can actually, using this type of printer, you can print a propeller using this stuff. So it's very cool printer. It's very precise. It's very the polymer, you have a lot of different polymer. In terms of this printer, you have the flexible one, you have a rigid one, you have a very different colors. You want opaque or you want transparent, you can use this kind of printer. Next slide will be stereolithography. So this is my favorite type of additive manufacturing technology for 3D printer is stereolithography, SLA. So it starts, if you look at here, this is Formlabs 2, and this is a schematic. Let me explain to you how it works, right? So first, you have a resin. Resin, basically the resin is in liquid form. It's semi-liquid. It's a bit viscous in terms of the viscosity. So what happens is that you have a laser. So you draw the structure in the CAD software, and you send that to this printer. So what we will do that draw the structure is that you have this UV light. It will cure the structure, and then you will build the structure layer upon layer to create the final product. So why I like this 3D printer technology so much is that it can create small structure. For example, in this printer, if you work it, if you know how to work it, it can go up to 15 micron of resolution. So this is kind of very cool. So next, which is the slide number 14, 24, sorry, 24, I will talk about application. So if you look at right now, if, when I talk about 3D printing, you said, okay, that's cool, but what is it used for? So one of the cool thing about 3D printing is that right now, you can build houses of it. So in 3D printing, it can be used in construction. So usually in this slide, if you look at it, if you look right now actually, to build a 3D printer, you have all this material, and then you have all this crane to build up the structure. You have to build up the wall. You have a lot of people. You have the workers. You have the architecture. You have the site safety personnel. You have a lot of stuff to create a house, right? Imagine you don't need all that. You just need a printer, a software, and you can print the house easily. So this is how they use it. So the house, the 3D printing house is actually being made. And even in Malaysia, they are bringing this technology in Malaysia to create a model house. So this is very cool. Imagine you don't really have to have people to do it. It's just you put it in software, and then you say, okay, I want this kind of house. It's just gonna print it by then. So it's very, very cool. So next is the 3D printing for automotive. So like I said before, one of the beginning of 3D printing was by automotive. So for example, you want to make a car structure, or the the body of the car. You don't want to make the real structure, right? If usually they use clay and stuff, but if you can do 3D printing, it's much easier. So you can just 3D print the structure and see whether it works, it looks cool or not. And now, then they create just a prototype base. But now you can actually 3D print a whole car. For example, you can print the tires using a flexible material. You can bring the chassis using a 3D printed metal. Using 3D printed metal, you can print the seats using different kind of plastic you want. You can print what kind of, even you can print the engine structure using 3D printing. Now here is Zinger 21C. It's the first 3D printed hypercar. So how cool is that? I think, like I said before, in the SME, they predicted in 2025. I think earlier they still already have prototype of 3D printing car. I think maybe like in the future you can buy it off the shelf. So for example, I want this car to be different structure. So for example, I don't want the car to be in the normal shape of the car, or you want it to be a triangle. You can just have them to print that car in a triangle shape, hexagonal shape, so whatever you want. So you have your own customizable car. So how cool, right? It's very, very cool. Next, which is food printing. Also, this is my favorite because I like to eat. So now you can print your own food. Imagine that, right? So for example, Cadbury is using 3D printing to print foods. For example, if you want to make, for example, you want to make presents, right? Present towards somebody. If you buy something from the shelf, you know that, oh, you buy something from the shelf easily. But imagine if you can print the chocolates. Like for example, you can print the face of your mom for Mother's Day. You print your face of your mom, or the birthday of someone. You can customize your own structure to make, like for example, a chocolate to make in terms of the face of your friends, of your parents stuff, or you can do customizable shape using 3D printing. I think Cadbury have done that. And then you can customizable for food. Right now, you can customize whatever structure. For example, if you go to like high-end restaurant where they do food plating and stuff, it's going to be difficult, right? For my hand, I can't really plate. My wife is always scolding me because I can't really good at plating. So that's the problem with my hand, a bit shaky. So, but imagine if you have a 3D printer, you don't have that problem anymore, right? You can just ask the printer to print. So now, in the future, I think where you can customizable your own food line. For example, for me, or for example, if you have a certain person who has diabetic, right? You can customize the food. So you maybe, for me, for example, if I want to go on a diet, so I can't have a lot of fat in my dietary, right? So I can customize my food in terms of how much percentage I want to have in terms of the meat, in terms of the fat, or in terms of the nutrient. You can customize it using your own preference. So for example, if I have a diabetic symptom, I like to eat certain food, but I can customize how what amount of sugar I want in my food. So this is a very cool stuff about 3D printing. And for example, if you look at like maybe this meat, this is kind of very expensive meat where you have all this white thingy will cost you a lot of money, but you can customize that to make it look cool. So this is a good thing about 3D printing food. I think in Malaysia will be coming very, very soon. Hopefully we can work on that. Okay, next, which is 3D printing fashion. Okay, this is, I think, for a lot of people, very, very cool. So you can print your own fashion. So you can print your own dress, what kind of avant-garde dress if you want. You can print jewelries. For example, you have your own customized jewelries. You can make it out of, for example, you can make it out of plastic, and you can code the structure of the, like for example here, a ring. A ring, you can code it with silver, you can code it with gold, you can do whatever you want. You can customize your structure rather than having them customized in like a shop or like a jewelry shop. It will cost you a fortune. You can do it by yourself, and you can just electroplate it using what kind of metal you want and create that. Here, I think the pink shoes might interest a lot of people. It's actually by it was given by Balenciaga, if I'm not mistaken, to Kylie Jenner. If I think you guys know about Kardashians, so you know about Kylie Jenner, where she was given this 3D printed shoes by Balenciaga, which cost you $5,000. For me, it's not worth it, but I don't know, that's fashion. So it's very, very expensive, but it can be printed using 3D printed your own shoes. So even like one of the shoes by Stephen Curry, I think it's Curry, I can't remember the name, Curry 7 or something like that. They use some of the parts are made from 3D printing. I think if you go to Pavilion, if you go to like the Adidas store and you look at the shoes, some of the parts of the 3D printing shoes was made out of 3D printing. So that's very, very cool. You can customize your shoes. Imagine you want your own shoes, right? You can print it. So for example, if I have a wedding at night, so my wife doesn't like the shoes, I can just print her own shoes. So that's kind of cool, right? You can do whatever you want. So next slide. So let me talk about a little bit about medical in terms of 3D printing. So everyone knows, I think we just we had 2 years of nightmare with COVID-19, right? With the pandemic, that's very, very crazy. But before this, for example, to get something ready in the hospital or in shops or everywhere, you have the raw materials. For example, the raw materials was in Brazil, it sends to the supplier, and then it goes to the manufacturer. The manufacturer will manufacture whatever things medical needs you need, and then it will use a plane or a ship or car or van, whatever transportation to distribute it to the retailer, and then go to the consumer. For in this case, hospital, right? But during COVID-19, next slide, 2029, everything just stopped. You can't really get things from anywhere, so you can't really do anything, right? So it's gonna be a bit tedious, and I think everyone experienced that you can't really go anywhere. All the borders are closed. Nations are not willing to help certain people. So, for example, if you have something raw materials, you'll be reluctant to share, right? So in this case, that happened during pandemic. So what you can do? So one of the medical things that, for example, here is the face mask or the face shield. If you look at the face mask, people are using 3D printers to print. Even for face shield, here's an example. My team and I, even the whole Malaysia at that time, the 3D printing community, we band together and print face shield. Well, at that time, frontliners have limited face shield. So what we did was we print the face shield structure. We put a PVC paper on in front, and it creates a face shield. So it helps a lot of people during the frontliners. So where they have limited resources. So we use that. So 3D printing community did a lot in terms of printing this and help the frontliners during COVID-19. And here, the next one with the scuba hat is that they modified the scuba hat to make it as a valve for ventilators. So you can use that kind of stuff. It's very, very cool. So that has saved a lot of people, saved a lot of people's life, where they can modify this kind of stuff using 3D printers. Next. Nowadays, 3D printings, I think you can, for surgery, for example, you have a broken skull, you want to replace that, you can use 3D printing to replace the skull structure. And for people who has disabilities, for example, they lost their arms or leg, you can actually print this kind of structure to form. Because if you do mass production, some kids, they grow up very fast. For example, this kid, the arm length or stuff will change very, very fast, right? If you have an injection molding, you keep on changing it, it will go expensive. So here you can customizable the structures of this person arms, and then you can help this kid to live their life easily. Now in the future here, they are predicting they can print a heart. So for example, if even kidneys and stuff, all your human body stuff, it can be printed. So for example, rather than waiting in line for like a long time to find a donor, you can print it. Hopefully this kind of technology will be available soon, and it can help a lot of life. Next slide. So here is some of the research that we did. One of the research we did is that we 3D print a nasal swab. At that time, in the beginning, there's a little bit shortage of nasal swab. So what we did is we designed this nasal swab. We work closely with people from the USA, where they already designed this kind of structure. They have the material, so we just modified a little bit that it's helpful to the frontliners. So we have this kind of structure, we 3D print it, and then we tested it, and it works similar to the conventional nasal swab. So this is very, very cool. So for example, if you have a shortage, we can actually 3D print this kind of structure easily. So we will not have a shortage on medical supplies for nasal swab. So next, so this is the other research that we did, is that we're gonna find some. So for example, if you broke your arm, you have to have this plaster of Paris to cover your arms, right? So sometimes for me, if I broke my elbow last time, what happens that it's gonna be very itchy, right? So if you wanna scratch your arm, so it's gonna be very itchy, and it's very, very difficult if you wanna take a shower, and for a while it smells so bad, you can't really do stuff with it. So what we want trying to do is that we're gonna want to customize our own, like the casting arm using 3D printing. So what we decided is that we want to do a biodegradable material that we can use to do all this with this kind of structure, where you can scratch whatever structure you want, this kind of stuff. So this is pretty cool. So next I will talk about aerospace. So this is, I think, a very cool technology where you can print stuff using 3D printer. You can print metal parts. You can print the whole rocket using 3D printer. For example, this is very, very important. For example, if you want to go to space, so we've seen NASA before, where they want to go to space. They will not bring all these kind of structures into space, right? For example, like they can't bring CNC machine. They don't want to bring injection molding machine. So what they do is they just bring a 3D printer. You can go in space using a 3D printer and can print whatever you want. So this is the cool part about 3D printer, because it can do a lot of functionality using only one machine. So you can maybe do a metal printing, or you can do polymer printing using a 3D printer itself. So this is pretty cool. So next, in aerospace, in our research as well, we can design very lightweight RF structure. For here example, we can 3D print X cavity slot antenna. So here we have this structure, we metallize it. It will be very, very light. It can be used in satellite usage. This is pretty cool. Next, on electronics, 3D printing electronics. So if you look here, if I think you guys watched Spider-Man before in terms of like Homecoming, right? So it's pretty cool. It shows that you can print the suit of the Spider-Man, right? I think that's very, very relevant right now. People can do that. So for example, here they can print 3D structures, or 3D printing can print circuitry. They can print X, Y, and Z using this kind of technology. Next slide. So what people do is that if you want to make a very complex structure, they use this is an illustration of surface micro machining. That's what they use to do this kind of crazy structure. So what they have is they have this deposition layer. They pattern the deposition layer to be a sacrificial layer, and then they deposit the metal on top of it, and then they take away the sacrificial layer to form like a conformal structure. But with 3D printing, next slide, so you can actually build that straight away. So you have what kind of structure, you can print it right away, and you can get the structure very easily. For example, here is a Vivaldi antenna. If you want to do that, you have very, very complex. The structure will be very, very tedious. So what we can do here is that we can 3D print it, metallize it, and it performs similar to what we have on the shelf. So here is one of the antenna that can go up to 3 gigahertz up to 18 gigahertz of frequency availability. So this is pretty cool, very lightweight, because if you want to do a Vivaldi antenna, you have to make it out of metal. Here, the main instrument will be in plastic, and then you just metallize it, and then it will be very, very lightweight compared to a fully metal structure. Next slide. Is also one of our research that we can make conformal structure. So this is very, very easily. You can do what kind of structure, E-patch antenna, or you have inverted patch antenna. You can easily do that using 3D printing. So, and then here you can make your own sensors, which is slide number 40. You can make different kinds of structure. You have 2 different parts. You can combine them together like a Lego, and then to form a sensor. This is pretty cool. Next slide, which is the slide number 41. 3D printing can also be used in education. So if you look at this, this is like If you want to know about things, you can use that maybe to put the name on it. And here, like in I think in Malaysia, I think um, Ranti, I think, have done a makerspace where you can design your own structure and stuff. And 3D printing is one of the tools that is essential for makerspace. So next slide, which is 42. So here we can do an education. For example, on your, I think it's on your left-hand corner, on the top left-hand corner, which is an atom, where you can make students to interact. So for example, the red one is the electron, and the yellow one is the neutron, and the blue one is the um, proton. So you can interchange, so people can be educated using all this stuff. So you have this whole structure, and you can tell the students how to use it. Next is the Chile Solat. This is very, very cool. Actually, if you look at the Chile Solat, is that this is a tool that we print to teach people with blind disabilities to learn how to pray. So this is very cool. So for people with blind disability, they can't really do a lot of things. They have to touch personnel to learn how to solat. So here they can just touch the figurine and learn how to solat. Next. So now when we talk about 3D printing before, they just have this kind of structure and it works like that. You just print, that's it. But now let's talk about 4D printing. So with 3D printing, you talk about length, width, and height, right? So what is 4D printing then? What's the next dimension in 3D? We have 3D, you have length, width, and height. But for 4D printing, what is the next dimension? So next slide. Time is the next dimension. So next slide, 45. Slide 45. So 4D printing is actually an action or a process of using 3D printing techniques to create an object that is able to change the shape or properties in predictable way over time in reaction to certain conditions. For example, exposure to water, air, heat, or electrical current. This is done. The first term of 4D printing was first used by Skylar Tibbets. He's the founder of a self-assembly lab from MIT. So next slide. If you look at this chart, if you look at this chart, 4D future technology is 4D printing. If you look at augmented reality, connected home, deep learning, but one of the high expectation of things that can be used in the future, more than 10 years, will be 4D printing. So what is actually 4D printing? So what is it? So next slide. 4D printing is that's 5 things you need to consider. The first thing is the additive manufacturing process, where 4D printing materials can be manufactured using FDM or SLA or SLS or even inkjet machine. Next is the smart material. How does it work? So one of the main things that you need to do is the shape memory. So it can change and go back to the same structure using 3D printing can use this kind of method to create this kind of objects. Next is the stimuli. How do you stimulate the material to perform whatever things you want? So there's physical stimulation, chemical, and even biological. Next, how it's interact, and how the next one will be material modeling, where you can do forward and backward production. So if you want to do something, you can interchange that using this kind of 3D printing method. So next, slide number 48. So for example, for piezoelectric, you can use mechanical stress. For electro-response material, you can use electrical energy, hydrogel, moisture, thermoresponsive, basically heat or temperature, photoresponsive responsive using UV light, magnetoresponsive using magnetic, even pH responsive using pH changes. So next slide. This is like a wheel where, if, for example, you want to do 4D printing. This is like to summarize stuff. So for example, if you want to make a smart device, you can use liquid crystal elastomer, and you use photosensitive product, and you use inkjet printing or SLS to create a 4D printing system. So for example, tissue, you can use magnetic field, or you use SMP composite or SMP multi-materials. If you want to do biomedicine or metamaterial, you can use pH or you can use chemical to make it multifunctional materials, and then you can use SLA or DLP to do so. So next, here is one of the technique that you use for medical industry, where they use 4D printing. For example, you have this architecture modified, and you can implant the into the bone the functional maturation, and it promotes this kind of stem cells, and it will repair the bone defect. So this is kind of cool things that you can do. So next, so here aerospace. In aerospace, for example, you have this kind of maybe you have a satellite, right? For example, you have a satellite and you want to power your satellite using a solar panel, right? So sometimes in terms of without, if you don't have any sunlight, would you let that for example, this solar panel to be open spread out? That will maybe giving you risk towards damaging it. So sometimes in space you have a lot of particles that move very very fast. It will just jeopardize your satellite solar panel. So what you do is that if you don't have any light, you can just close that together. So 4D printing allows you to do so. Rather than having mechanical stuff, it just retract everything, and it just do it without mechanically, without using mechanical. So next slide, which is slide 52. So when we talk about this one, you can use a lot of things using this. So you want to make robot printed soft sensors. You can use 4D materials, 4D printing to do all this stuff. For example, you just send an electromagnetic structure towards, or electrical current towards that material. It will close up, or you release that electric field, it will just open up or close up. Then you can make cool robots out of that. So last 53. So the benefit, like I want to tell you the real benefit of it is that you can customize whatever you want. You can fast prototype. It's toolless because you don't have to use a lot of other tools to create sustainability. Material range from ceramic, plastic, metal. Now you can print tissues. You can print a lot of crazy stuff using this. And then simplified assembly and low cost. Here's like a joke where you can build a 3D printer using a 3D printer. So you can do what kind of stuff. You can do crazy stuff using all this. So my conclusion is that 3D printing or 4D printing is a technology for now and also for the future. The capability of 3D printing is beyond astonishing. You can do what crazy stuff. You just have to find the right materials, the right process. I think it will be a very very exciting in the future with this technology. I think you can find amazing applications in terms of this, in terms of research. I think kids will love that. For engineering, I think it will be very very beneficial. For physics, actually, it will generate a lot of research in terms of that. The future of 3D printing is limitless as the tools are still being developed, and this is only the surface. If you see 3D printing, 4D printing, people are predicting that you can do 5D printing. So that's kind of cool. So I would like to say thank you to everyone. Oh, sorry. Thank you to everyone. Lastly, I would like to give like a giveaway. So I will ask two questions. So if you can follow me on Facebook or Instagram, if I want to ask two questions, who can PM me or DM me two right question, I will give you guys maybe a Starbucks or a Shopee giveaway card so you can use. So the first question is that what are the most common used 3D printing technologies that is used right now? The clue is they will show you guys what it is. And the second one is what is my favorite 3D printer? So if you guys can do, that would be so nice. So if you guys want to tell me the answer, I will pick randomly who give me the answer, and then I'll give you the giveaway. So I would like to say thank you so much to everyone. That's a very great pleasure to talk about what my passion is, which is 3D printing or additive manufacturing. Thank you.
Thank you, Doctor, for the interesting presentation for our webinar. So next, Doctor, could you please tell me about the FDM technology for the live demonstration?
So FDM technology, I think, is one of the most common used technology for 3D printing. So what it does is that it has this filament. it will go into the nozzle and it will print the structure. So you have certain temperature in the nozzle that will from the filament will be in solid, and then it will change into a semi-liquid form, and it touches the platform. It will solidify and create a layer upon layer structure. So I think you guys will give how it's demonstrated, right? Using that.
Yes.
So that's
Yes.
going to be very, very cool. So this is the technology. I think this is how the printer works. So you can see it's designing, sorry, a layer upon layer to create the whole structure using that. I think people are using it in schools where they want to create a very fast prototype. They can just use FDM to do so.
Okay, thank you, Dr. Ifat, for the amazing explanation. So I hope all of us can get and learn many new things about the 3D printing technology from what the doctor have present. Okay, doctor, you can give like rest for,
Okay,
because
thank
we
you.
will go ahead to take some time for the questions.
Okay,
Okay, just a reminder, please be sure to type your or leave your question into the chat box if you have any in our YouTube channel and the Facebook Live. Okay, so basically I have two questions from my
okay,
my view.
okay.
For the first question, I would like to ask you about the what are the limitation of the 3D printing technology.
So for 3D printing limitation, that's I think there's still a lot of things that make it limited. One of the first thing is the speed. For a 3D printer, it takes a while to create an object. That's one of the limitation, the speed wise. And then the other thing is with the speed. If you can't have the speed, you can't have mass production. That's one of the limitation. You can't do mass production very easily. But the best thing about 3D printing is customizable. That's the main objective. And then the other thing is materials. So not, yeah, there's abundant of materials that you can use for 3D printing, but you can do much more. So maybe you can interchange stuff and you can do crazy stuff using materials, which can be helpful for certain other application rather than what I shown before. That's, I think that's the limitation.
Okay, thank you, doctor. So I have one more question.
Okay.
Are there any possible ways to overcome the limitation of 3D printing?
I think there's a lot of new ways in terms of to be designed. For example, there's can't remember the name of the technique. Is that they use SLA, where they combine it with different technique, where they can easily fast print structures using SLA based technique, and they can just use these lights and then just bombard light to create an object very fast. That's very cool. I can't remember the name. I'm so sorry, I can't remember the name. It was on top of my head, but that's a technique they can use. And also, I think with the development of faster machine, I think that can be easily be done, as well as materials that can solidify very fast or structural that can be designed very fast. I think that will help reduce this limitation stuff.
Okay, thank you, doctor, for the explanation. So we also get some question from the Facebook Live from Shahira Syari. She asked, Assalamualaikum, Dr. Ifwat. I have one question for you. What are the significant impacts of 3D printing technology on the aerospace industry?
I think the impact is very huge. For
Mm.
example, right now in NASA, they did a competition, I think 2-3 years back, is how to design a house in space for Mars exploration. So what they did was that people designed different structures, and they used the main technical usage of technology is 3D printer. Now they're predicting that in space, in Mars, they want to build a house using a 3D printer. And like for example, in aerospace, right? For example, if you go to space, you can't really bring all the, for example, your tools, your nuts and bolts, or your screw, or all the gadgets, right? So you don't really know what you're gonna be using in space. So one of the technology that it can easily be done is that you can print whatever you want. So for
Mm.
example, you want to print a screw in certain shape during at Mars, you can just buy a printer. So this is very cool. So and then the best thing about 3D printing is that you can customize the structures depending on the usage. So for example, something got broken in space, you can't really go back to Earth, right? So for example, you are in Mars, you can't go back to Earth. Oh, I want this stuff, so they're gonna ship away there. What they can do is that they can just print it there using 3D printer. I think that's the impact. The impact is huge. A lot of things can be implemented using 3D printing for the beneficial of aerospace exploration.
Okay, okay.
Yeah.
Thank you, Doctor, for the explanation. We also get the question from the Facebook Live from Nur Atika. She asked, Assalamualaikum Dr. Ifwat. I have one question. Which industries are able to utilize and benefit the most from the growth of 3D printing?
I think every industry uh, going to be beneficial. For example, the food industry with food printer, medical. I think yes, huge potential. You can 3D print bones right now. You can 3D printing implant stuff. So that's going to be beneficial in terms of, for example, in terms of automotive. You can print your own structure of the car. I think most of the industry right now that is available will be beneficial by the introduction of 3D printing technology.
Okay, thank you, Doctor. So we also get the question from the our YouTube live from
Okay.
Lee Hao En. He asked, "Hi and Assalamualaikum. Sorry, what is the material used for the printing demo just now? Is it capable of printing any engineering grade materials such as PEEK?
Okay,
Such
yeah.
as P.
For example, for FDM, I think there's some printers that can use peak to print this kind of structure. I think it's already been done. I can't remember the name of the printer, but it can be used for FDM. It can be used to print high quality grade like peak or PEKK in terms of using a 3D printer. That's materials. I think it will be developed. They are already been developed and it can be used very fast.
Okay, for the next question, we also get from the YouTube live from Nazira Yusuf. She asked, "Hi and Assalamualaikum, Doctor. Very interesting.
Okay.
May I know what factors influence the manufacturing speed of 3D printers?"
Okay, one of the factors is the type of printing that you use. Sometimes for FDM, it's going to be a bit very fast, but inaccurate. If you have SLA, you have got to be very fast, but you're going to be very slow, but very accurate. So there's a bit of trade-off for different type of technology. So that's the cool part about 3D printing. And for materials, why is it slow? Because sometimes the materials can't really solidify as fast, or the structure is not very well. The structure of the material is not very good. So that is one of the problems that we're facing with 3D printing.
Oh, I see. Okay. Okay. I think we got one last question,
Okay.
which is from Wan Ahmad Al-Tamis from the Facebook Live. So he asked, Assalamualaikum Dr. Ifwat. I have one question regarding post-processing of 3D printing. Why sending 3D printed PLA is more difficult compared to ABS?
Okay. For in my experience, for PLA, it's pretty brittle. That's why the structure is very brittle. When you set away the structure, it's going to be a bit brittle, and it will just make it a bit unsmooth. So it's going to be a bit difficult. For PLA, the structure is very well compact, and it's very easily to send it off. So that's for my experience. So usually, I think there's different technique. Some people use for me, in my case, I can use wet sanding. So wet sanding means I put some chemicals in terms of in my sanding material sanding sheet. So I can sand it using certain chemicals, and I can sand it very easily. It depends on how you. So I think most of the people use dry sanding, which they just use a sandpaper and they sand it like that. But if you want to make it very cool, very nice, you can use wet sanding, where you have certain chemicals, but you combine them together. So in my case, I combine my secret own recipe, and I combine that. I can polish that very easily.
Okay, I think that's all for the question.
Okay.
It looks like we have covered all of the questions. So, Dr. Ifwat, is there anything else you wanted to cover before we wrap up this presentation?
Oh, I'm just gonna like to share that with 3D printing and 4D printing or additive manufacturing, you can do a lot of crazy stuff. You can do wonderful stuff, and I hope Malaysia will focus on that kind of technology, and hopefully it will be a part of the conventional manufacturing, and we can use it in many available industry in the future and right now.
Okay, thank you, Dr. Ifat, for your amazing presentation, and now we will proceed to the souvenir giving ceremony. But before that, we will present. We will show you. We will show you the 3D printing video trailer. We would like to invite our group director, TS Dr. Hu Wailun, to present the gift for our honorable speaker as the token of appreciation for his presentation today. Thank you so much, Dr. Ho. Next, next we would like to present. Sorry. Next, we would like to present the gift to our group director as token of expression for giving us this opportunity to organize this event. So I would like to thank you to Doctor for your support attending our webinar today. Thank you everyone for participating in our webinar session today. Stay tuned for any upcoming video and thanks again for joining us today, and we will see you next time. Thank you.